Alright, so the last method we'll be learning about in our Bayesian lecture series is the hypergeometric method. The hypergeometric distribution, it's again can be modeled using a hypergeometric function in Excel. So why is hypergeometric distributed questions different from binomial questions and Poisson questions? So it comes down to whether or not the population of interest is large or small relative to the sample you're collecting. So the classic example of a hypergeometric problem is a bingo cage. So you've got a cage with 40 numbered balls inside, and you turn the cage over and over and pull one out at random. So the chance I get a ball numbered 21 to 40 is 50%, because there's 20 balls labeled in the top half and 20 balls labeled in the bottom half. So that's great. But if we roll the cage and draw again, the chance I get a ball that's 21 out of 40 twice is not 25% like you might assume. So binomial would give you an answer of 25%, because you can only give it a constant probability of getting a yes answer of 50%. But the reality is that since we've pulled a ball out, we don't have 20 out of 40 that work, we have 19 out of 39 that work, making the chance of pulling 2 slightly less than 25, as 24.4%. And this is occurring because the population we're selecting from, 40 items, is as small relative to the sample size we're collecting too. If we had a bingo cage with 100,000 balls in it, the fact that we pulled one out and kept it wouldn't make a material difference in the probability estimate. But because we only have 40, it matters. So hypergeometric is specified basically exactly the same way as binomial, but rather than specifying a probability of getting a yes, which we can't do because the probability changes every time, instead we specify a total number of yeses and a total number of things in the pool. So you can of course back out that probability yourself, right? So if I have 40 balls in the cage and 20 of them are numbered highly, that's a 50% chance, but hypergeometric is going to adjust that probability as draws are made. And so that's all done automatically through Excel. So if I want to know the chance of pulling 2 out of 2 in the upper half, it would be hypgeom.dist 2 yeses out of 2 tries, where there's 20 yeses out of a pool of 40. And then 1, if it's cumulative, that would be 2 or less, or 0 if it is exactly 2. We want exactly 2, so we do it like that. So let's do an example of a hypergeometric question. So let's suppose that you're a salesperson working at a timeshare sales opportunity. So there are 10 people in the room that might buy a timeshare, and of those 10, 4 actually are buyers. So we can ask, what's the chance I get 2 sales in my first 3 attempts? So this is a hypergeometric question because we want 2 yeses out of 3 tries, but the probability of getting a sale isn't 40% after the first sale. So it is for the first sale, but it's not for the second sale. So we have to do hypergeometric, hypgeom.dist. So I want 2 sales out of 3 tries. There are 4 yeses in my population and 10. And we want well, let's see, what's the chance I get 2? So we want exactly 2, so I'm going to do 0. Now notice, if there were 2 yeses in the pool, that would still be valid. So then you would write 2, 3, 2, 10. So in general, when entering data for the hypergeometric, it starts from small to large, but that's not always 100% of the time true. So it might be the case the first number will certainly be smaller than the second, and the third will certainly be smaller than the fourth, but it's possible to have a second number larger than a third number. Essentially what that would mean is you're trying more often than you could have possibly gotten yeses. So you're guaranteeing that you will not have 100% success, but that may not be the goal in the first place. All right, so the chance of getting exactly 2 sales in the first 3 attempts is this. But maybe we want to know 2 or more sales. That's probably a more reasonable thing to do. So that would mean if we're doing 2 or more, if I put a 1 here, this is now 2 or less. So the opposite of 2 or more is 1 or less. I'm going to do 1 minus. So it's 1/3 chance. So that is using the hypergeometric function in Excel. So to distinguish hypergeometric problems from Poisson and binomial, or binomial you have a decimal that tells you a probability. Poisson you have a decimal that may or may not tell you a probability. It will not tell you a probability. It may not even be less than 1. And you only have 2 numbers that you need to do a Poisson. You need 3 for binomial. For hypergeometric, you need 4. So you need a number of yeses, number of tries, number of yeses in the pool, and number of things in the pool. That means they stick out. The fact that you get 4 data points looks like a lot of data. So you can usually tell by the feel of the question what the appropriate method would be using that as your indicator.